Dear students, in this lecture, we shall investigate a very famous topic from microeconomics, and that is known as expansion path. Basically, what we are going to do is to apply the first order condition from the optimization in it. Let us see. Just for your reminder, a graph is shown that tells you about what expansion path is. As you can see that the output is expanded, but at the same time the inputs in an equal amount, they have been increased. So this shows the long run process of the expansion of the output. The scale of production is being increased. What you can see in mathematical terms is that it is the comparative static aspect of the producer's equilibrium, because in producer's equilibrium here what we are going to see is that what is the impact on the output once we change the inputs. So it is the impact of the exogenous variable or the independent variable, in this case on the endogenous or the dependent variable. So what we do is we keep the PK and PL, that is the rewards of capital and labor, the ratio the same, because if we let them change, what will happen is that the budget line will change its slope, and that gives rise to a more complicated situation, and we are starting with a simpler situation. Therefore, you can see all of these budget lines, they are parallel. And what we want to do is to see that how these successive increases in output happen and how they are achieved within those constraints of ISO cost lines. And this is what we have mentioned here. We are trying to achieve those least cost combinations. Here they are. This is the first combination, the other combination is there. Moreover, what we see is that there is a shift of isoquants, and they give rise to new points of tangency, 1 point, 2 point, and there will be other points as well, right? So there are new points of tangency in this process. और जब इन points को हम join करेंगे, we will get this thing जिसे हम expansion path कहते हैं, because it is actually showing the expansion of the output of the firm following those constraints. Therefore, once revising this concept, we are going towards the application of the first order condition of optimization in this case. आप जानते हैं, when it comes to consumer equilibrium, the first order condition is as follows. So we are going to use this is actually the producer equilibrium, right? So once we use the standard form of the Cobb-Douglas production function, it looks like this. And if we can find out the values of MPK and MPL, we can put them into the condition. And here they are, the values they have been calculated of the marginal product of capital and marginal product of labor. And they have been put back into this condition. There you are. यहाँ पर ये values को हमने substitute किया. There is a lot of cancellation happening here, right? And the result would be this. You can pause the video and see how this cancellation has taken place. उसके बाद हम इसे रेसिप्रोकलाइज कर देंगे. इनकी पावर जो आप देख रहे हैं लेबर कैपिटल की, दे हैव टर्न्ड पॉजिटिव. नाउ इसके बाद व्हाट वी हैव इज पीके और पीएल इक्वल टू दिस. हाउएवर, वी वर इन सर्च ऑफ द लीस्ट कॉस्ट कॉम्बिनेशन, एंड दैट कुड बी हैड इफ वी ट्राई टू फोकस ऑन द अमाउंट्स ऑफ कैपिटल लेबर वी शुड बी पुटिंग इन द प्रोडक्शन प्रोसेस. तो हम इसीलिए के ओवर एल की वैल्यू को फाइंड आउट करें इंस्टेड ऑफ पीके ओवर पीएल. सो इसे हमने क्रॉस मल्टीप्लाई किया एंड वी गॉट दिस एक्सप्रेशन. फाइनली, अगर हम इक्विलिब्रियम के नोटेशन को इनकॉर्पोरेट करें, इट विल बिकम के एस्टेरिस्क ओवर एल एस्टेरिस्क. So in this way, the answer that we are likely to get for this least cost combination is going to be a constant. Why? Because alpha is a constant, beta is a constant, and we have already assumed that the prices, they are not changing. Therefore, once if we assume that all of these are positive, we are going to get a positive, a constant answer. And it is likely to be positive as well, because the coefficients, that is alpha, beta, as well as the prices, they are positive. Therefore, all points on the expansion path shall show us a fixed input ratio. So the answer of K asterisk over L asterisk it is going to be a constant, for example 2. So it's a fixed value, and we are going to get a fixed answer, not just numerical, rather a fixed answer as well. What it does to our expansion path is that it gives rise to a straight line, because it is just like that कि अगर हम 2/1 करें, 4/2 करें, 6/3 करें, जवाब एक ही आएगा. सो जब हम इन दो वैल्यूज़ की बात करें जिन्हें हम तकसीम करें, ये k और l की वैल्यूज़ हैं और वो y और x एक्सिस पे हमने प्लॉट की हुई है. बट जब हम उनकी रेशियो लेते हैं वो सेम आती है. इसका मतलब ये है कि जब हम उनकी रेशियो के पॉइंट्स को मिलाएंगे तो वी विल बी गेटिंग दिस अ स्ट्रेट लाइन, विच यू कैन सी इन द डायग्राम दैट द एक्सपेंशन पाथ वाज अ स्ट्रेट लाइन. सो हमने अपने रिजल्ट से जो मैथमेटिकली हमने कैलकुलेट किया, हमने ट्राई किया कि हम जज कर सकें द शेप ऑफ द एक्सपेंशन पाथ. इसके अलावा मैथमेटिकली अगर हम बात करें तो ये जो प्रोडक्शन फंक्शन था, इट वाज होमोजीनियस, ड्यू टू विच what we got was a straight line of the expansion path. So again, homogeneous production function is likely to lead to an expansion path which is a straight line. In the theory, आपने पढ़ा होगा in microeconomics that the expansion path can also be a non-linear relationship. However, it was not discussed in this lecture. It was limited to a straight line of an expansion path. Thank you.